All right, sorry about that. I have learned that we were muted. I will start all over once again. I'm honored to be presenting to you some of the work that I did for my master's degree, which is looking at the pedology of typical soils of the Kamuli District. Kamuli District is a district where very many ISU students have gone and visited, and I hope that all of us in this seminar can have a chance to visit Uganda. And so I did my work for my master's thesis there. So I would like to start by acknowledging people who helped with this work. My major professor, Dr. Bores, thank you. Dr. Andrew Manu, Dr. Gail Noneki from Horticulture, and Dean David Aka. I would also like to thank colleagues, Amber Anderson, Nicola Timbers, Matthew Streeter, Jude, who is in Uganda, Maureen Beza, who is an Iowa State University, Uganda program staff, Sheila, who is a grad student here in horticulture, and Rebecca, who is a PhD student here in the Department of Agronomy. I would also like to thank the Center for Sustainable Rural Livelihoods, which is under the College of Agriculture and Life Sciences and is doing work in the Kamuli District. Then I would also like to thank the Iowa State University, Uganda program staff, who are based in Kamuli full-time, 365 days of the year. We are going to look at pedology in East Africa. I will talk about Uganda and Kamuli District. Then I will talk about the Center for Sustainable Rural Livelihoods, which is under the College of Agriculture and Life Sciences and does its work in Kamuli. Then we'll dive into my study that I did in the district. So a general introduction, we know that soil is an essential resource, especially to places that rely heavily on agriculture, which is Uganda. However, access to soils knowledge is a problem, especially in sub-Saharan Africa. We, as the soil science community, can address this problem. This is a paper that was published last year that says pedology is a disappearing skill in East Africa. This is very scary, given that many of the concepts used in pedology today, such as the catena concept, originated, most of the people who are known as fathers of pedology did their work in East Africa. So this paper looked at a number of publications in pedology that came from the East African countries between the period of 2010 and 2019. I would like to acknowledge that Dr. Boris and Bradley Miller have a recent paper published in October of 2021 that looked at soils in one of the districts in Uganda, but this study unfortunately did not get to 2021. However, they found a total of 56 papers published in the field of pedology. And Uganda, which is my country, had only one paper. And that paper was published between 2012 and 2013. So what are we doing? I'm hopeful that by the time I leave Iowa State University, I will improve this statistic. This is from the Web Soil Survey. And I just went in and I was like, oh, let me look at the agronomy and ag engineering farm. And I have the soils information. And I went in and I was like, oh, I want to look at the corn suitability rating of the farm. And it is easily given to me. But in places like Africa or sub-Saharan Africa, we don't have this. So I hope that as we go on this journey, at one point we'll have a web soil survey for sub-Saharan Africa. So what is Uganda and where is Uganda located? Uganda is a landlocked country in East Africa. It has a land area of 24.1 million hectares and has a population of 48 million people. And we grow each year at 3.3%. 48 million people and 24.1 million hectares of land. That is a scary statistic. when it comes to land allocation, and given that Uganda relies heavily on agriculture. 78% of the labor force in Uganda relies on agriculture, but we see that land to the number of people. So if we are 48 million this year at 3.3%, next year we will probably be at about 49 million people, and we are increasing each year. This will be a very huge problem. However, an interesting statistic is that greater than 45% of the population of Uganda is under the age of 15. And as I had said, agriculture is the main source of livelihood, and it contributes 37% of our gross domestic product. So this is a map of Africa, and you can see Uganda is located in East Africa. When I looked up, as I was trying to show, I was more interested in the soils. So I pulled up a major soil regions map of Uganda. But in Uganda, we use the WRB terminology. But when I came, I'm glad I came, I now know the USDA soil taxonomy that I incorporated in my study. However, this map needs updating. This is a map that was drawn in 1945. And it is the map that you can easily find on the source. So we need to update this right now. And I hope that we, as people who are interested in the world, will probably do this together. So where is Kamuli District? Kamuli District is located in Eastern Uganda. It is, so in Uganda, we are a very diverse group of people. Kamuli District is located in the Kingdom of Busoga. So I want to acknowledge right now that I'm not from the district of Kamuli. I'm from the southwestern corner at the border of Uganda and Rwanda. That is where I grew up. But the district of Kamuli is one of those districts that has faced its own fair share of challenges. It has a 15,000 hectare land area and has a population of 600,000 people, but it keeps growing, and 60% of the population are women. The people there rely mainly on subsistence farming, so they farm specifically for home consumption and sell the surplus. But the average education of the people in there is P5 education in the Ugandan system, which is equivalent to 5th grade here in the United States. So they face a number of challenges, but the most pressing are poverty and malnutrition challenges in the district. So with those challenges, the Center for Sustainable Rural Livelihood pointed out this district, and they started their work in there in 2004. They started their work with an NGO that was established called Vedico. However, in 2014, they finally became registered as a separate non-government organization known as the Iowa State University Uganda program. They have staff who are on ground, and they have associate directors here on the ISU campus. And Dr. Boris, who is my major professor, is the associate director for agronomy and land use. So this program collaborates with Makerere University, which is how I made my, my connection with the Iowa State University Uganda program. I was a student at Makerere, and I did my internship with the Iowa State University Uganda program, and a number of students who decided to spend 6 weeks of their summer in Uganda doing internships. That is how I made my connection, and I got hired as staff. And through that journey, one of the donors started the Borel Global Fellowship Program that brought me here to ISU to pursue grad school. They constructed a training center known as the Pirigiti Rural Training Center that has a 99-year lease, and that lease started in 2018. So that shows commitment that ISU is in the district for the next 99 years. So this is a report they made for some of the progress they made last year. You can find this online. Then that is the newly constructed training center where students can, this training center has a library, has Wi-Fi, and so if you go there, trust me, you will be in good hands, and they have staff who will be there to take care of you, answer any questions that you have. That is me in 2019, January. Dr. Boris, and a bunch of students who decided to spend their spring semester in Uganda. That is how I met Dr. Boris, not knowing that I would be here as his student, and Dr. Aka. Then at the training center, they also have a demo farm where they try to show the people the best management practices for their land. What is the climate of the Kamuli District? They have a distinct wet and dry season. The rainfall distribution is bimodal. The mean annual temperature range is between 19 degrees Celsius to 25 degrees Celsius. Sorry about the Celsius, but in Fahrenheit, I have a diagram that shows Fahrenheit highs of 83 and lows of 62 degrees Celsius. The rainfall range is between 1,000 to 1,200 millimeters per year. In inches, I think that is 7.4 inches.
40.
40. Yeah.
Close enough. We don't know.
Yeah. So we have a bimodal distribution of rainfall. So we have two distinct wet seasons, what they would call the wet seasons. This is the time when farmers go out and plow their lands, and it starts in March and goes up between April. So the middle of April is when we have the highest amount of rainfall. Then it goes down in June, July, then again goes up starting August. So the people of Kamuli have two distinct seasons where they do agriculture. They go out and work with their farms. So during the wet season, you will find them planting. And then during the dry season, they are harvesting and doing their post-harvest handling practices, which is sun drying their grain. And then again, preparing for the next season that is coming, the next rain season that starts in August. So the relief of Kamuli consists of flat-topped ridges, gently sloping hillsides and narrow valleys that drain the Nile River. So the Nile River is the western border of the Kamuli District, and Lake Choga is the northern border of the Kamuli District. I will show that in the Google Earth image. So that is Kamuli. And so to the west, this is the River Nile, and then to the north is Lake Choga. So the landscape pattern is mainly tied to rifting. So Uganda is found within the Rift Valley. So these are two land masses that probably will separate. So that rifting very much affects the landscape of the Kamuli District and stream evolution. So the River Nile, you can see very much that there are streams that very much shape the landscape of the Kamuli District. Then I found this whole elevation heat map that shows, you can see that the low areas are where there is water. So the River Nile very much puts like the western part of the district in the low. And then we have like the north that is very much covered by the Lake Choga. And as you can see, sometimes when we have very wet rainy season, a huge part of the Kamuli District floods. So the geology of the Kamuli District is underlain by Precambrian granite with evidence of sediment from the Quaternary age around Lake Choga and the River Nile. So what were the objectives of my study? My objectives were to characterize and classify the soils of Kamuli District according to the USDA soil taxonomy and the World Reference Base. Then, in addition to that, we wanted to explain two benchmark catenaries in the Kamuli District. And so these catenaries were not named Kamuli Municipality and Butansi Sub-County, but we are the ones that named them that way because of the locations in which these catenaries were formed. So these study sites are farmers' fields that we went to that work with the Iowa State University Uganda program. So we went there and dug pits. So we had a total of 19 sites that we visited. And so you can see Kamuli town, then Butansi sub-county, which is where one of our catenaries was found, and then Namasagali, that is at the western border of the district. So what we did is we went and dug profiles. So we had someone to help dig the pits for us. Then we described the soils and we collected samples from each horizon. Then these samples were sent to Makerere University Soil Lab for analysis, and they did a pH. Then they did organic matter using the Walkley-Black method. They did the total nitrogen using the Kenjal digestion. Available P, they used the Bray P1 method. Then the exchangeable cations, which is potassium, calcium, magnesium, and sodium, they dissolved these in neutral ammonium acetate and used atomic absorption spectrometry. Then they also did the particle size analysis using the hygrometer method. So those are pictures of us in the pits. I had Amber there, Nicola, Matthew. So thank you very much to those people that helped out with this work. So what were some of the morphological characteristics that we saw? The pedons were deeper than 1 meter, except where we encountered plinthite. And it is not that we did not dig deeper when we encountered the plinthite, but the plinthite was hard enough that we could not dig through it. So where we encountered this plinthite, the pedon would be like 15 centimeters deep, and I have some pictures that I will show later. And then the well-drained pedons had a dark brown topsoil overlaying reddish brown to red clay B horizon. So the profiles became redder in the B horizon. So the poorly drained pedons exhibited gray colors and redoxymorphic features in the B and C horizons. Then the epipedons had a predominantly sandy clay loam and sandy loam textures, but we saw an increase in clay content with depth. When I show what we were seeing out, we can see that the soils are more in the sandy clay loam texture. Here in Iowa, you would see very many of them in the silt loam, clay loam texture, which is totally different, but this is a tropical kind of system that we are working with. And it is underlain by Precambrian granite, as opposed to here where we have glacial till. So then when we try to sort of depict the particle size distribution with depth, we saw that sand was higher in the upper horizons and decreased as we moved down into the B horizon, but clay is the opposite. So clay actually increased with depth. So the increase in clay with depth could probably be as a result of lessivage. So this clay is dissolved in solution and moves with solution down into the B horizon, or there is possible clay neoformation that is going on in these systems that would probably understand if we did the mineralogy analysis. And then the chemical characteristics, the pH range was high. We had soils that were from 4.9 to 7.7. Then the soils had low to medium available phosphorus ranging from 3.5 to 20.7 parts per million. The organic matter range was also high, but it was generally high in the epipedon and decreased with depth. The total nitrogen was low and it ranged from 0.1% to 0.25%. Then the exchangeable cations were ranging from 0.4 to 3.87, but a major order that we saw that calcium was higher than magnesium, which was greater than potassium, and sodium was the lowest in our soils that we saw. So when we went into classifying the soils, I classified the soils up to the family level of the USDA and the tier 2 of the WRB. So the WRB system has 2 levels of classification, which is the reference soil group, and then you add qualifiers, which are principal qualifiers and supplementary qualifiers, which is what they call the tier 2. And in the USDA, I went all the way up to the family level. Using the soil taxonomy system, the orders that we saw, we had alphisols, that is an example of an alphisol that we saw. We had entisols, which were these sandy, poorly drained, and they were usually located on terraces. Then we had some mollisols, which were majorly close to the River Nile. So these were located in the Namasagali area. Then we had some altisols, which were more related to altisols, but had higher exchangeable bases that we used to classify them into the altisol. Then we had oxysols that had very low exchangeable cations and had plinthite in them that made them not very deep. So we'd usually hit 50 centimeters and we could not go any further because of the limitation by plinthite. Then we also had some vertisols. This was at the training center, which had very neat looking pressure faces, so silicon sides, which was cool to look at. And I will also expand further in my catena that I developed. Then 37% of our profiles were classified as oxysols and 21% were classified as altisols. So majority of our soils fell into those two orders. So what are some of the pedogenic processes that we were seeing? We saw that clay lessivage, which is that increase in clay with depth or possible clay neoformation. Bioturbation is huge in this area, in that farmers actually farm the top of termite mounds, and you find that the corn there is doing better than what is in the sides. And a cool thing that I saw on this trip that we went is that we did not see any fizzing in any of the profiles, so calcium carbonates, until we had a soil that was on a termite mound. So when we dug a soil in a termite mound, we could not dig any deep because the termites came out and started disturbing us. But we dug up just a ped and we picked it. And when we poured hydrochloric acid, we had fizzing on those soils that came from termite mounds. Then the increase in exchangeable bases with depth could show that pedogenic leaching is a major feature that is going on in this place, given that we have a wet and dry season. So when it is the wet season, the rains are high and people are tilling these soils. So we see that leaching is a major feature. And this was showed by the exchangeable bases being higher in the B horizon than the A horizon. Then organic matter was higher in the epipedon and decreased with depth, which showed that humification was also a feature that was driving many of the soils that we were seeing. Then plinthite, which was a major feature that we were seeing. So plinthite is this hard, it's not a rock, but it is hard, it's iron that is cemented, and as a result, it is hard. So we would usually find it in these soils, and when we would find it, we would not go deeper. And a hypothesis that we put forward is iron is reduced during the rainy season and moves down by eluviation to form these zones of accumulation. Then in the subsequent dry season, it precipitates and crystallizes in those zones, becoming cemented as plinthite. So when we would encounter it, we would not go any deeper. And these are majority of the soils that we are seeing at the summit positions in this point. And farmers farm these places. So this is a major limitation, because if we have this, that means rooting depth is limited. And so this is a major crop limiting factor that we have to look at. So when I came to my catenas, I have this catena that I named Kamuli Municipality Catena. So it's new, you will not find it anywhere. I named it because we dug this place in the constituency known as Kamuli Municipality. But what was cool is it's found at the training center, the ISU training center built in the Kamuli District. We had 3 profiles. One was at what we referred to as the summit. We had one more of the back slope position area, and we had one in the toe slope. And these are actual profiles that we were seeing. So I sort of drew, so we had elevation data for the different profiles. So I drew sort of like a depiction of what our landscape was, and then showed the profiles on and how they were located at the different facets of the landscape. So we had, and then some of the relationships that I saw is clay content increases as we move from the summit to the toe slope. And then the air horizon depth too increases. So it was lowest though it was low at this profile that was in the back slope position, it was highest at the foot slope position. And then organic matter too was highest in the profile that was in the foot slope position. And that profile was classified as a vertisol, but it had poor drainage, which is why we had the endo-aquat. So the water table kept on fluctuating in this position. And as a result, as you can see, the B horizon is glayed. So you can see there is that black, and then we have like the gray B horizon. Then we had a stone line too. So I went ahead and drew a cross section of the landscape. And what we are seeing, we see that there was a deeply, strongly weathered oxysol at the summit, which was not different from the soil that we had in the back slope. And then we had this cool stone. So we were seeing these quartz rocks that were still intact. So we were like, there's something going on. And it was very, because you can see in this profile here, we have like these quartz rocks that were still intact. And then the same was in this profile, but we did not see those in the foot slope position area. So when I drew my cross section, I was like, there's a stone line in this profile. And reasons that we gave is, again, in this landscape position, we had termite mounds. So these termites were moving the finer feet. So this soil that is finer, they were moving it and using it to build their termite mounds, leaving behind the quartz coarse features that became distinct in the landscape as a stone line. And then we see there's some detachment of soil sediment that is being deposited down. So that thick A horizon, and then the glade horizon that we had that was very distinct in the B horizon. Then I had another cool catena that I had. This was located in a farmer's field, and he had a huge chunk of land. So we had a transect of profiles that we looked at. And as you can see, there is this distinct difference. The soils here are red, while these are sort of like white, sandy, clay, sandy soils. So this was also very evident when we dug our profiles and described. So here, instead of the clay content increasing down the profile, down the catena, the sand content was actually increasing, which was the opposite of what we were seeing in the Kamuli municipality catena. And the same applied to organic matter. So organic matter actually decreased as we moved down the catena. And again, the soil in the foot slope position was also poorly drained. So the influence of the water table was also very evident in this catena, in the Botansi sub-county catena. So I also drew a cross section of this catena. And in this catena, we did not have the stone line that we had in the Kamuli municipality catena. And again, the profiles, the two profiles at the summit and the backslope area were classified as oxysols, while the two profiles at the bottom were classified as entisols. And as a result, these were deposited by the river that was flowing in this part of the landscape. And this is very evident on this picture, because even the farmer said that this part of his farm was not farmed, because whenever it rained, that part was flooding. And it was very evident that this place was located on a terrace. And as a result, it was located in a floodplain of the Nile River. So during the rainy season, the farmer was like, I cannot cultivate the area, so I rent it out to grow sugarcane. So he rents it out to these huge companies that grow sugarcane for manufacture. So he doesn't use it for his own, but he rents it out to other people to grow sugarcane in that area. So a summary of what we saw is the soils of the Kamuli are classified as alphisols, entisols, mollisols, oxysols, which was the same. So we also classified these soils, and we also had altisols and vertisols across the catena. The predominant pedogenic processes are humification, leaching of base cations, bioturbation, so these termite mounds and clay lessivage. And then again, our catena has confirmed that there is a systematic variation of soil properties along the hill slope in the study area. And that is all. And we were here, we were on the shores of the River Nile in Namasagali. And so I would like to thank you. And at this point, I will welcome questions, comments, and insights. Thank you.
Since you're at the conclusions, so you have across the catena, so you
Yep.
have all those soil orders, or many of those soil orders
Yep.
in one catena.
No, because we did not. So we had, so the two catenas that we had oxysol, then vertisol in the foot slope position. And then we have the oxysol, and then the atisol down. But then the mollisols and these beautiful black air horizons, like the beautiful black soils, were more in the Namasagali area. And the farmers there did not have huge pieces of land to let us have so we were not able to explore all the catenas that are possible in the area, but we would assume we would see these distinct relationships play in the different landscape position areas. If we had, this work was done in 1 week. I thank Dr. Boris. He took me to Uganda in the January of COVID. So January before COVID, before COVID. So I did the work. I had hope that I would go back the summer to do a deeper study, but then COVID happened. And so we had to move forward. So we used the work that we did in 1 week, but had I gotten the chance,
10 days.
yeah. So we had 10 days to do this work, but my vision was to do a huge study and try to explore all the distinct catenas that we had in the Kamuli District. So,
All right, so I have a practical map question.
yep,
You brought up the map from 1945.
yep,
And you said it needed to be updated.
yep.
All right, so maybe a setup question, but probably thinking about the legend of that map. Do you think that map needs updated? Or can we trust? I wrote myself a note. So do you think that map was more reliable in 1945 than it is today?
No.
Francis, make sure you repeat that question.
Yes. So Dr. Miller asks whether the map that I have of the major soil regions of Uganda is
More reliable?
more reliable. I would say for now, since we don't have the soils knowledge, since we don't have, I would say the web soil survey, I would say this is a starting point for us to make this reliable. So I will not say it's not reliable because the people in Uganda rely on this. So this is what we have available right now. On the reliability piece of it, I don't know if I would say it's reliable. If I don't want to commit saying it's reliable or not reliable, but at the moment it's what we all go to try and understand the soils of the Uganda.
Well, and that's a great contrast with the soil survey.
Yep.
So the web soil survey is really spatially detailed.
Yep.
And so really the question I want to get to then, and you'll have a fun time at so with the different soil orders you're observing even across the catena,
Yep.
when you make a more detailed map, would you anticipate having soil orders as the legend, or would you actually include lower levels of soil taxonomy in the legend?
I would So if we had soil orders to start with, I will appreciate the soil orders. But if we can go down to as much detail to capture, so if we can go down to the lowest level of classification and capture as much detail as that, in that if a person is going to, I'll be like, hey, it's a kaolinitic soil. The person will appreciate it better. So if we are to have as much detail as possible, but I want to start small and go big. So for now, if we could have a map that shows the orders, from there we can make recommendations to farmers. But if we can go further and make it as detailed as possible, if we can even have series, we can make, the farmers would appreciate the series more than these orders that could not show as much detail as possible. So, yeah. So an orders map is highly welcome. Then a series map is highly, highly welcome, but let's start small and think big. So thank you.
There's a question that came in that's lengthy, so I put it in chat box for everyone. If you want to open that up and read that.
So, okay. It says you explain the formation of plinthite in the context of poor drainage. So iron is reduced and accumulates in the subsurface, but was plinthite found only in poorly drained soils? Actually, in poorly drained soils, we did not see plinthite, but it was in these well-drained soils. So the context in which I explained the formation of plinthite is more to do with just leaching in solution, not to do with the soil being permanently poorly drained. But it is because we found plinthite more in the well-drained soil, so like the soils of the summit and the back slope that were well-drained. And in these poorly drained soils, we did not see any plinthite formation. So I would assume that plinthite formation is more to do with this wetting and drying of these well-drained soils. But in poorly drained soils, that changes, I think, the mechanism in which that is operating in that poorly, because plinthite has to, when you look at the color of plinthite, you see that it is iron 3. So it's more of iron 3, but then so gray plinthite, which would be evidence of iron 2, was not. So in the poorly drained systems, I think the mechanism falls apart that leads to formation of plinthite. Yeah. So it is not to do with the poor drainage of the soil, but rather this wetting and drying, like wet, dry, then precipitation and crystallization of this plinthite, and not to do with the constant poor drainage of the soil. So
for instance, are you saying that during the rainy season, there's enough rain coming through these systems?
Yep.
That within even what we classify as a well-drained soil,
yeah,
that you get enough chemical reduction that the ferric iron in the system switches to ferrous iron.
Yep.
It migrates down or migrates to another place in the profile.
Yep.
Where there's enough oxygen that it
oxidizes
ferric iron from ferrous. So you're really seeing these microsites of changes from ferrous to ferric. And once it goes ferric, it turns into an iron oxide or hydroxide.
Yep, that is exactly what is going on. I hope the person could hear you speak, because that is a way better explanation than what I did.
So well drain can be chemically reducing at times.
Yeah.
Because
of the rain.
Means overall there's oxygen in the system.
Yes.
Not that every minute of every day there's oxygen in the system.
Yes.
Okay.
Yeah.
There's another question online from Dr. Thompson. He said, what was the connection of the plinthite
to the stone line? Yep.
Oh yeah, you can see that.
Yep. So actually we would see plinthite and the stone line, but the stone line would be above the plinthite. So if I go back to my beautiful So in here, so this was the maximum depth that we would dig to. But then you see that the stone line is evident above the plain site. So the stone line was still in there because we would manage to dig through the stone line, but when we would hit plain site, we would not go any deeper. So this shows that the plain site was below the stone line. So we had a stone line that we were able to dig through and see the quartz rocks, the distinct quartz rocks. And then when we would go deeper, because we would encounter the plain site, we would not be able to dig through the plain site. So they were not connected together, but the stone line was located in an area of the profile that is above the plain site.
And I have to ask a clarification question on Dr. Thompson's question and what you answered.
Yep.
So the stone lines we're describing, for example, in this Katina, were they stones that were quartz stones from the Precambrian granite?
Yep.
Or were they stones that were actually broken plintite? And I asked that because
Yep.
Dr. Miller and I, we mentioned we did some work together in Uganda at different sites. We've seen both types of stone lines.
Yep.
So which type of stone line did you have here?
We had the distinct, so quartz from the Precambrian granite
Okay,
that was that was not tampered with. So it was distinct in the profile. And then the plain site, so below it,
Right.
would dig these chunks of plain site that would
okay,
move out. And so it was both of the, we had both of
Yeah.
them in our catena, and the same applies to the other catena too. We had plain site in those landscape positions, but we didn't have those quartz rocks that were distinct for us to classify it as a stone line. Yep.
Francis, I've got a question for you.
Yep.
I enjoyed the talk, by the way. Very nice
Thank
job. You listed a whole bunch of other metrics. I know you only have a limited time here.
Yeah.
And you showed us, I think, the texture with depth.
Yep.
And then you showed us a few other things like soil descriptions. Is there anything that surprised you from those other measurements? You know, you said you sent to the lab at Macquarie there, you had pH,
Yep.
organic matter,
Yep.
anything that popped out of you after you looked at those data? You had a lot of time.
Yeah.
It was during COVID, right? You were
Yep.
waiting for the data to get back. Is there any other things you didn't share with us that was really surprising or exciting to you?
Let me see the pH, like how low the pH can get in these systems, but then farmers still plant and they assume the system is doing. I don't have a problem with my soil, but then when you measure the pH, it's like acidic. So, but then the farmers still plant with no lime and they still go on every other season. So this was something that was pressing, and so we in our future work we hopefully want to go back and see how I don't want to say the farmers are resilient because they complain. They are like, this season I did not do well, but then they keep going and doing it because that is their life. So like how low? So in school we are like, the ideal pH is 6.5. If your soil is not 6.5, at least 6.2, and your plants are doing well. But in this system, we had farmers where a farmer is confidently saying, this is my land, I will plant it each season, and the pH is low, but they still plant. So I don't know if that is resilience, but that was a shocking feature that even me, I grew up in this system, but I grew up in a different part of which is way cooler, and we have a totally different agricultural system. So we are in Uganda, they have agroecological zones. So we are in a different agroecological zone as compared to the people of Kamuli. And this was something that was very surprising to me to see that farmers still go each season and plant, and they don't care what is happening in their system. So Yep. And personally too, growing up, I remember we grew up farming these systems, but we never knew what was going on. So growing up, I was like, I should do agriculture and try to understand what is going on, because we all planted. So growing up, we all planted because our parents were doing it. And so they do it because they have to survive. But then they rarely understand the scientific system of it. So they are doing it to their best, but then it's their knowledge. It's not the knowledge of the scientific community. So personally, I think if we embraced science a little bit more, we would do better than we are doing right now. Yep. So that was something that surprised me. The people of Kamuli are happy despite all these challenges going on. And when you go to Kamuli District, you see them, they are a very welcoming community. But from a person who looks at it from an outside angle, you see that the people have challenges that need addressing, but they are happy in their own challenges that they are facing. So
Well, nothing else has come through online. Any questions?
Yes, Francis,
Yep.
you piqued my interest with the study you started with Pedology during
Yep.
East Africa. I'm kind of curious how you might define pedology and how that paper was measuring
yeah, so
the existence of pedology.
So in this paper, so what they did, so Karuma is a person, if you go online, you'll see that he's a pedologist who is very interested in Kenya. So what he did is he went to Google Scholar, Web of Soil Science, and looked up papers that had either a soil survey in East Africa, pedological characterization in East Africa, and pulled these up. So he did not compare. I do not want to say he compared to the rest of the soil science community. So like how much is published in relation to the United States or what is in, but he just looked at the papers that were published, whether it is in just that talked about pedology in East Africa. So he just pulled up and was like, okay, I'm going to Google Scholar today, look up at papers that are published in pedology, then pulled those and counted. Then he went, and then later he aggregated them into the different countries. And what is fun is Ethiopia is the one doing well, and it is because they have the Ethiopian soil science, I think, soil information system. So Ethiopia was the one that was doing well, and he attributed that to the fact that they have a division within their government that is pointing at soil science and saying, hey, so they started an Ethiopian soil information systems. So this person was like, Ethiopia is doing well, and that can be attributed to that. So the rest of the East African countries, do we need to look at soil science and be like, hey, we need the soil science division that, yeah. So this person just pulled up papers that were published, and look, that was the data they used. So.
Sure, but I'm going to press a little bit further on how, and now you need to give your personal opinion on how to define pedology.
Yep.
Or if you don't want to put yourself in the line, you can state
Yep.
how this author defines pedology. But
Yeah.
as you do that meta-analysis and you're looking at papers and
Yep.
deciding which paper to put in which pile,
Yep.
you know, what criteria would you suggest is what makes the pedology pile? What topics?
So I assume, to me, I believe pedology is I don't want to cause debate, but pedology is a branch of soil science that deals at understanding the formation and evolution of the soil and forming these frameworks in which we understand soil formation and how the soil is changing. So I don't want to cause community debate or anything. So I assume the person pulled up papers that looked at soil formation, how these soil systems are changing, and not the soil fertility aspect of it, so things to
But how
do
about
with,
soil survey, that count in there?
yes, so soil survey,
Formation
soil-
and mapping,
soil
classification?
formation mapping and classification. So that is what they looked at. And so they even say that there are lots of papers published to do with planting, fertilizing, and then doing all those, but they did not consider those in their sample space. Yep. So I don't want to cause problems by saying, hey, pedology just looks.
It's interesting to consider.
Yeah.
Because there's been papers saying that like soil science is disappearing from the United States.
Yeah,
But it depends on how you.
yeah.
By the way, Francis, I feel good, 1 or 2, possibly 3, but I think 1 or 2 of those papers from Tanzania, I'm an author on. So I feel good that I'm doing a little bit of work.
Yeah, I think it is between 2016 and 2018, your paper and Johnson's paper. Yeah. Then in 2021, we have one where you are co-authors, so.
Yeah. Well, we'll have a lot more one of these days.
Yep.